Okay, so we were in this example. So it says gear A with 24 teeth is mounted on shaft 1. It meshes with gear B on shaft 2, which also supports gear C. Then the third, shaft 1 and 2 are 220 millimeter apart, and so are shaft 2 and 3. On shaft 3 is a gear D with 14 teeth, which rotates at 400 rev per minute. The center distance between shaft 3 and 4 is 300 millimeter. And then they said use a module of 10 millimeter and determine the following. So we are asked to determine the number of teeth on gear B, C, and E, the rotational speed of shaft 1, 2, and 4, and the purpose of the gear. Okay, so let us check the solution of this example. Okay, so on our given data, we have TA, 24 teeth, and then we have TD with 15, and then we have the speed of the gear D, which is 400 rev per minute, and then center distance for shaft 3 and 4 is 300 millimeters. And then we have a module of 10 millimeters. So, for number 1, we are calculating the teeth on B, C, and E. How to find or how to calculate number of teeth. We're going to use the center distance formula. Okay, so for center distance formula, it says C is equal to module into D plus TE over 2. So it depends there which number of teeth you are looking for. But since we are looking for B, C, and D, that means now the values for here and here will change. So in this case, we'll start with shaft 3 and 4, right? Let's go back there in our drawing so that you will see the. So this is our shaft 3 and 4. 3 and 4 have the gear of E and D. Yeah, can you see that? This is the two gears. Yes. So to find D to find E, since D is given. So to find E, you will use the center distance for D and for shaft 3 and 4. So that means to determine gear E, you will have to use gear D and gear E. Okay, so there is why on this formula we have TD plus TE, because they are connected in the same shaft. So the center distance for 3 and 4 is equal to 300, which is given, and then we have the module of 10, which is given as well. Then, what's happening? You guys. Okay. Okay, so the number of teeth for D is given, it's 15. Then you substitute to calculate your TE. So my answer was 45. Okay, so we were looking for number of teeth for B, C, and E, right? Then center distance 2 to 3 from gear 2 to 3. Let's go check our gears 2 to 3. 2 to 3 is this one. 2 to here. That means it's C and B. So the center distance from 2 to 3 is 220. But on the textbook they wrote 300, which is wrong when they were calculating the number of teeth for TC. You're right, love. Okay, so in this textbook it's wrong. Okay, so we have 220 for center distance. There's our 220, and then we have module, and then we calculate for TC. TC is 29. Then for shaft 1 and 2, we also have the center distance of 220. It's 229. Okay, should be it's this textbook. Nama error. On this textbook there were so many errors. Okay, so we substitute the values of the center distance, which is 220, and then the module, then we calculate for TP. Do I want to take this down or do I continue? Okay, so number 2. We are asked to calculate the speed of shaft. So the speed of shaft that we are calculating, that means we are calculating the speed of shaft 1, 2, and 3, since the speed for D is given. So the speed for D and D is 400, so we are looking for a speed NE, NC, and NA. Okay, so NB will be equal to something else. Okay, but since they are meshing each other. Okay, the speed of the shaft, let's start with ND. You have this formula. So ND meshes with NE. That is why we have ND times TD is equal to NE times TE. Then we substitute the values for ND and TD. Then we solve for NE, which was 133.33 ref per minute. So that was the speed for NE, since ND is given. So NE and ND, they are on the same shaft. Right? Okay. Yes. No. We same lane or same side. Then to find MC, we're still gonna use the same ratio formula, which says ND times TD is equal to MC times TC. So our ND is given 400 times 15, and then we are looking for NC, and the number of teeth we have for C. Then our answer for NC is 206.896. So NC and ND, they are equal. NC and ND, they are equal. Yes. Yes. NC and NB njalo. It's B. Oh yes, it's B. I wrote it. It's 200. So NC equals to. Oh yes, it's NC and B. So NC and B, they are mounted on the same shaft. So the speed for C and B, it will be equal. Then we calculate NA. NA will use 1 and 2 for shaft 1 and 2, which is A and B. So that is why we have that ratio formula of NA multiplied by TA is equal to NB times TB. Then we substitute the given values and then the answer was 172.413 rad per minute. Are we still together? Okay, then for number 3. Number 3, they said we must find, okay, what is the purpose of gear D? You can answer this question according to your own understanding, but I also want to know what's the purpose of gear D. What can you say about gear D? Yes, please. Okay, so gear D, the purpose of gear D is to change the direction of gear E. So that's the purpose of gear D. Okay, so there was example of 4.3. Then I will give you a homework. Tomorrow we'll do another example that has young modulus so that you will understand this part here. There you go. Or else you can try home. I want us to do more formal applications or on Wednesday. We can continue with this chapter tomorrow and finish it. Then on Wednesday we do application. Yes, from Wednesday. But this is still like N5 revision. So, some years we've done in N5, and they're still the same, still one and the same thing. send the homework on group chat, and then so even if you are not here, but I'll send you the homework, then you will do it, and then we'll check it on Monday. That's it for today.